Good morning or lunchtime, I would say, everyone. Very happy to be here and to present today about the playbook, my presentation, and it's about model as a service. The title is Playbook for a Sovereign Model as a Service Platform. I'm Camille. I work at Red Hat. I'm a specialist solution architect. I mainly focus on AI technology. So, perhaps you've had your coffee already this morning. Perhaps you had two, if you're like me, or if you were a bit tired free. I'm not at that level yet. But let's imagine you're the CEO of a company and you need to provide coffee for your employees, right? There are different ways to do this, as you can imagine. There is the first way, which I will call the shadow coffee way. By the way, the images in this presentation, as a disclaimer, are AI generated by Gemini. So we have the shadow coffee way. What does that mean? That means that we have a company, let's say, with 50 developers, and every one of these developers needs to buy their own machine, their own grinder, their own beans, and as well as their own water. Everything is then expensed on the corporate credit card. But does this make sense, right? Maybe, maybe not. Let's look at it. You encounter some issues. First of all, everyone uses those coffee machines every day. You have developers that love coffee, and they use all the coffee and a lot of electricity. So a fuse is blown. Then we have a second issue, right? It costs a lot of money. If each one of these developers need to buy their own coffee machines, their own bean, their own water, as well as their own grinder, it really costs some money, right? As you can imagine. Then the cleaning team needs to work a bit harder, perhaps have some more hours assigned to them, because this creates a mess. We have beans everywhere. We have a lot of powder everywhere, a lot of water is splashing around the office. And also perhaps the beans some employees are buying, they are not, they are expired. So what means is that on top of that, where you have employees that might be sick and have sick leave for a few days, and also you have beans everywhere. The whole thing takes a lot of space, 50 developers, 50 coffee machines. Why are we talking about coffee, you might ask me, right? You came here about model as a service. Now I talk to you about coffee. You might think about coffee if you're like me. But why are we talking about that? Because essentially it has a lot of similarities with the model as a service and especially with AI. So let's first talk about the water. Water in this analogy, the analogy of water in this approach is the prompt. I think you all know what a prompt is, but if you have the coffee machine, the smaller coffee machine, right, you need a bit of water. You can perhaps do 2 or 3 coffee if you have perhaps a small Nespresso. And you have, for an AI model, if you have a small AI model, you can use my favorite prompt, which is, how do I exit Vim? Interestingly, I prompt this all the time. However, if you have a bigger prompt, right, you haven't turned off an EC2 instance on AWS, and you like to find out exactly why and how, you will need to upload your 500 pages billing report to this model. And this is not possible with a small coffee machine, right? So not possible with the small AI models. You need some context window. You need a bigger context window, and therefore you would need kind of a bigger infrastructure. Now, let's briefly talk about what are tokens. So LLM, they consume tokens, right? They don't consume characters. They get billed as well by tokens. And this is text chopped into words, syllables, or single characters. So this is the example I've done with, nice, yeah, with Tick Tokenizer. So I have inputted the prompt we've done before. And as you can see, there are some numbers below. So what are the numbers? It's a model-specific tokenizer. Translate this chunk into a single unique ID, right? So if you would put this text again to the tokenizer, the ID will be the exact same. So each number is assigned to one token. Yes. It's important to know different models uses a different tokenizer, right? It depends for which tokenizer they have agreed on when developing the model. So for example, you have the Quen model, right? You have the token count of 28 in this case. But if we do the exact same for the Gemma model, then you have a 10 token count for 33. So you have your local laptop, which is very good, perhaps for smaller models, such as 1 to 3 billion parameter, I would say. However, for a bigger laptop, and when you need a model which has a longer context window, you might need some infrastructure, such as a GPU cluster, for example. Now let's talk about the parameter, which is in our case, the coffee beans. So parameter are especially the model weights, and developers download open weight models files to their local machine, and then they use an inference, and then they can use that model. There is, however, a hardware limit. A standard laptop can only fit that much, as I've mentioned before, and bigger models obviously require a GPU cluster. But perhaps you're like, yeah, a small model, it does the job, even if the response is not the best. Perhaps I use a quantized model, right? They can be very strong as well. Let's say 4 billion parameter, for example, it's enough. I have my coffee anyways, even if it's not the best coffee, let's have it. But you can have a lot of challenges due to that, because everyone works in silos. You have then a lot of duplicate models all over the place, not perhaps the best quality, and it can lead to very poor AI performance. So this is taken from Hugging Face. It's a screenshot from Hugging Face with the Red Hat AI validated models. Those are models validated as from Red Hat. And what I want to show there is that it every time shows how many parameters you have. So for example, you have here GPT OSS 20 billion, right? So you can see how many parameter a model is. You can also see when a model is quantized. This also shows there, for example, this one. So yes, so with this, you can a bit calculate what hardware you need. And then we have the one of the last analogies, which would be the inference engine, which is in this case a grinder. So what is a grinder? It's the inference engine, exactly. So if you use the mocha pot, perhaps, and you like to, or you use a real coffee machine, and you grind maybe 1 or 2 cups a day, you perhaps have a manual grinder, which are also very good. I mean, I have one of them. However, it's not the most efficient one, right? Let's say you have 20 guests at home, you need to make 20 coffee, then you need a lot of muscles that I may or may not have. This analogy is for the Ollama inference engine, which is great. It really works very well for on a single machine. You want to run your local model, you want to make it happen. That's great. But it's really built to brew exactly 1 cup of coffee for 1 developer at a time. And then there is the more powerful grinder, which in this analogy is VLLM. You might have heard of it in the past. It's an inference engine for Gen AI, and you're able to pull really 50 shots of espresso at the time. You're able to really send it multiple requests. So in a nutshell, now we talked about shadow AI at the start, right? What can this lead to if everyone spins up their AI model, their small AI models on Ollama, on their own laptop, right? It can lead to a lot of issues such as duplicate model deployments, fragmented governance, and resource underutilization. For example, perhaps you will have then one application which will use with a small model, which will use a full GPU, for example. This would be one example, which wouldn't be, you would underutilize the resources. Why not use multiple smaller models on one GPU? And if every developer has their own model, it just doesn't make sense for scalability. But then you're like, okay, I'm tired of this. Too many issues. My cleaning team is tired. The maintenance team is tired. Let's do something else. Let's expense the coffee. So let's go to the local coffee shop, right? We sign a contract with them. 2 years, I get coffee from this coffee shop for every employee. So every employee goes to this coffee shop with the corporate card, and what happens? So this can cost some money, as you can imagine, right? If we see the price of coffee of Zurich nowadays, it can be very shocking. 8 francs last time I paid. And also the price spikes. So the coffee shop can really decide. You are locked in with this coffee shop. You have a contract for 2 years with them. The coffee price, maybe tomorrow, they say, we double the price because perhaps rent went up, or perhaps they want to pay their employee more, etc. They might have their own reasons. However, not ideal for us because this will go up. And the most important one, we all know this developer in the company that loves to gossip with the barista. So the developer gossips with the barista about the code, the very confidential code or the very confidential data. And then the data leaves the organization. The barista knows everything and tells everything to everyone. Then there are no secrets in the company anymore. So this approach, what can this lead to? So this is, of course, as you might have realized, the analogy for using an external API, perhaps from a hyperscaler. The data leaves the organization, goes to perhaps a data center. Depending which hyperscaler you use, you might be able to choose which data center you are using. However, you still don't know what's happening in the background. Most of those models are not open source. There are a lot of risks associated to it. It's not very much a sovereign approach. There are also unpredictable costs, right? Some hyperscaler also have some contracts for 2 years, and they lock you in, and perhaps you will need to also use their whole infrastructure to run this API correctly. So you will need to use their whole ML capabilities. And also, it's less flexible, right? You cannot use the tools you want. So there are also some geopolitical changes that are happening nowadays. And staying in the control, keeping your options open is very important. Sovereignty has gained in importance recently. Now we looked at both approaches, shadow coffee, as well as expense the coffee. It works. We do get our coffee. However, not the best, right? What could be the best approach? So how about I invest once in a coffee machine, in a big barista coffee machine, which costs also a lot of money, but this would be a big one-time investment, and everyone can get their coffee as they want. So the analogy is for a model as a service, and it's, so short is MaaS, and it's a way that the common models are served centrally. The developers consume them through a standard API, but it's all within your infrastructure. It can be a hybrid cloud approach. However, it can be on-prem as well. And the GPU resources are shared and then governed. What I will explain today will be a bit on Kubernetes. This approach we have will be on Kubernetes, just to let you know. So we have the users. We have the end users use the application. The developers, they use the API from the model as a service. For an API gateway, the AI engineers, they work on the models. The data scientists, perhaps, they fine-tune it. And then we have the shared GPU resources. GPUs are very expensive nowadays, so it might make sense. So let's get ready. Let's get the beans ready. Let's get the machine ready. And let's try this out. Let's deploy a model. So to deploy a model, I am now using a tool called OpenShift AI. However, the open source version of it is Open Data Hub, and you can of course reproduce that yourself. So you have here a list of model you can use. For example, I would like to use the 7B model. You have here the model card, some information. You would like to deploy the model, and here you can say, where is my model located? This is in the OCI. Generative AI model project, which is, if you are familiar with a Kubernetes namespace. And here you go. Have the serving runtime. We will use LLM because we want our GPU to be used efficiently, as well as the advanced setting of add a MaaS endpoint. I will not spin up this model now because it takes some time to spin up. I already spinned up a model. But just to show you, this is how it would look like in the front end. But what happens in the back end? So in the back end, so we deploy the model. It translates all the front end configuration I've showed you into something called the Kubernetes custom resources. If you are familiar with Kubernetes, you might already be aware of it. And this becomes the single source of truth, the declarative blueprint for the deployment. So what is the custom resource in Kubernetes? So actually, around 10 years ago, I was working in London as a barista in Starbucks, and some people had very interesting order. My favorite one will remain, I think, probably for all my life. It was Frappuccino light, low sugar, but 10 pumps of cream. That was my favorite. So yes, this is similar to the custom resource in Kubernetes. So it's an extension of the Kubernetes API that allows us to create the tailored blueprint. It's usually combined with a controller, and the controller revises this file, and it gives us a fully automated declarative system. How does it look like, a custom resource? It's really a YAML file. The controller does actually all the job. But this is a YAML file. And in this case, because I have deployed the Qwen 4B model just before, this is how it looks like. So we have the model, we have where it is stored. It's stored in OCI. We have the router, a bit of networking specifications, as well as the resource it needs. So I did request one GPU. So to sum up, the custom resources starts a deployment, and the deployment gets everything from the OCI, which is container registry, exactly, open container registry, and it's I have used the Quay. I'm not sure if you're familiar with it. Feel free to check it out. And then from there, we pull in the model weights as well as the container image. Then we get the pods ready, and then we have the pods, and the pods are then assigned to a node which have a free GPU, right? So this goes all automatically under the hood. And additionally, you have the opportunity to have a replica, to have some replicas of your model. And if you have a replicas, you have different pods of your model, and then you can have there is an internal load balancer which is created for you. So that is, it balances the load. Okay, great. So we have done this. So this is how it looks like. So this is how so I have spinned up the 4B Qwen model. We have an external endpoint. It looks like this. And then we can generate an API token. Everyone can use it. And we can see the status. So this is great, another image generated by Gemini, as you can imagine, but everything's working. However, we have one developer, he loves coffee, or he loves consuming the model. Every minute he's having, what is this Linux command for creating a file? What is the Linux command for Vim, etc., etc. So what do we do? So we create tiers, right? We want to have tiers. Perhaps there is a free tier, a premium tier, and an enterprise tier. So this is also done under the hood. This is something you can figure in the front end, and this is all done under the hood in the YAML file, and it auto-generates Kubernetes role and role bindings. And then we have also the opportunity, it also under the hood, an HTTP route is created on your behalf and submits it to the Kubernetes API. Okay, great. So we have configured the tiers. We have configured the networking. However, I have not done anything myself, right? This happened all automatically, but this looked a bit in the back end. You can still check if you want to be on the safe side. Everything works. So now back to our coffee machine. I would like to have one espresso. Let's use our model. I've showed you before how to that you can just use the API endpoint. And Sarah Jones is an enterprise user. So those are the limits of what she can use. As you can see, is 100,000 tokens within 1 minute, and she can use 50. She can hit the model 50 times within 2 minutes. Okay, great. I have already tested it out and tried it multiple times myself. I will not run live demos in this session because we don't have enough time. However, this is how it looked like, right? 50 requests, it works, and 51 requests, it didn't work anymore. So great, we send the prompt to the model. And yes, so how do I exit Vim? You are funny. You can also, of course, change the system prompt if needed. You are a funny AI assistant. You are designed to answer questions in a concise manner and make a joke about coffee. We send this, and the reply would be, pretend you didn't edit anything. This is also something I've done multiple times. Otherwise, your coffee is probably more powerful than your Vim skills. I have to be honest, the LLM sense of humor is not the best. I don't find personally LLM very funny, but every now and then I try. And now we would like to, this worked, everything worked out. We tested out the tiers. We tested out the LLMs itself, right? Everything's working, but now we would like to have a bit more of information about exactly what happened, observability, right? We would like to monitor our coffee machine. So I have generated this Grafana dashboard. I've created this Grafana dashboard, and you can display different metrics, right? So for example, total of authorized hits. This one, I have used the model a lot this morning, trying to generate some traffic so I can show you something. And then authorized hits by user and tier. So I'm the admin user, as you can see. So you can see that this has peaked here. And hourly authorized hit by user, so you can really track everything you want. An interesting thing you can track as well is, as you know how many which user used how many token, you can also charge it back to the respective department, right? For example, if you have the HR department, which uses, let's say, 10,000 tokens, so you can charge this saying, okay, 10,000 times perhaps 0.001, and you can charge this back as in the Kostenstelle, how we say in German. So we have just seen the monitoring of the coffee machine, and another very interesting fact as well is that, you can really monitor everything you want. I'm just showing you some example, is the GPUs. So there are the DCGM project, which is by NVIDIA, and you can have a very good GPU dashboard with the NVIDIA metrics, right? So here you can see 36.9 degrees watt, and you can track a lot of metrics as well. I have heard that GPUs have burnt in ETH twice. I don't know if this is correct. If someone can confirm this to me, I'd be interested. So it might be good to know the temperature. Yeah. Okay, this I've shown, this I've shown. Yes, user tracking for billing. That might be very interesting as well. And a very attractive, I would say, feature of this is that there is no gossiping with the barista. The data stays within your premises. You can really choose where your data is, whether it's a hybrid cloud approach or whether it's on-prem. This is not a problem. So, conclusion. There are, of course, as you can imagine, multiple teams were engaged in this model as a service, and everyone is happy. So the application developers, they are not AI experts. They're really struggling with those heavy files, messy Python environments, and those crashing laptops because perhaps they don't have enough RAMs, and perhaps the models are very slow because they're running on CPU and they don't have a GPU. With MaaS, it's not required, right? You can just have your OpenAI compatible API endpoint. Then we have the IT and platform operations. We have the GPU sprawl, right? They're very scared of this. If 50 developers ask for 50 GPUs, this will cost a lot of money. And this might not make sense. So they prefer to share those GPUs efficiently. So with MaaS, you have centralized efficiency. You host powerful shared GPUs on a Kubernetes cluster. Then we have the security and governance team. They are very scared of shadow AI because they might also use perhaps external APIs, right? They might run their own local models and they might have their external APIs and unmanaged local models. So they want absolute control, and enforce rollback and rate limiting keeps all AI traffic secured on the private network. Last one would be the data scientist. Wasting 80% of the time really fighting with the Kubernetes infrastructure. Perhaps they don't have the knowledge, and they use MaaS to have the automated deployment, and the platform spins up pods, wise networking, and automatically wise GPU. And the finance team, they're very happy because then they can charge back the cost in an automated manner to the responsible cost center. Thank you for listening to my presentation. I hope you enjoyed it, and I hope you learned something today. Thank you.